Hello there, and welcome. Tonight, we're going to sink gently through the layers of time, not thousands of years, but millions. Beneath our cities and oceans lie buried stories, and maybe, just maybe, civilizations. Not ours, but something older. What if humans weren't the first? What if another intelligent species once walked the earth, one now lost to deep time, their artifacts dissolved, their cities swallowed by stone? This isn't science fiction. It's a question scientists have seriously considered, called the Silurian hypothesis, and tonight we'll drift through 100 astonishing possibilities, from fossils and forgotten epochs to energy signatures and planetary scars. We'll explore the eerie clues that suggest we may not be the first to call this world home. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Beneath your feet lies a record older than language, older than bones, older than the continents arranged as they are now. Earth's crust is not just stone, it's memory. Each layer tells a story of fire and flood, of ecosystems rising and falling, of time compressed into minerals and fossils and radioactive decay. But there's a question buried deeper still, a quiet, unsettling question that has flickered at the edges of scientific thought, sometimes dismissed, sometimes revisited, always lingering. What if humans are not the first? What if, before us, there was something else? The Silurian hypothesis was named with a touch of humor borrowed from an old science fiction episode where a race of intelligent reptiles ruled Earth long before we came along. But the idea itself is serious, proposed not by conspiracy theorists, but by respected scientists, including an astrophysicist and a planetary climatologist. Their curiosity was not sparked by ancient ruins or myth, but by data, chemical anomalies, extinction events, and the vast silence of deep time. They weren't claiming there was an earlier civilization. They were asking, would we know if there had been? It's a haunting idea because it challenges one of our deepest assumptions, not just that we are alone in the universe, but that we are alone in Earth's history. It suggests that we might not be the first species to burn fuel, to build cities, to shape the planet in ways that could echo long after we're gone. And it forces us to confront the staggering scale of geological time, where millions of years pass like a blink, and even mountains vanish. Most of what we build will not survive us. Our glass and steel towers, our roads, our machines given enough time, they crumble. Organic matter decays, metals corrode, plastics degrade under pressure and temperature. Even concrete, in the right conditions, breaks down within tens of thousands of years. That may sound like a long time, but in Earth's 4.5 billion year lifespan, it is less than a breath. The fossil record itself is brutally selective. It favors hard things, teeth, bones, shells. It prefers sudden death in the right kind of mud, where oxygen is low and minerals are high. It ignores the soft, the scattered, the subtle, and the deeper you go into time, the more the record erodes. Rocks melt, plates subduct, oceans rise and fall. Entire landscapes are ground into silence. So imagine this: an intelligent species rises, not 100,000 years ago, like us, but 50 million. A civilization, perhaps reptilian or something stranger, evolves complex thought, language, tools. They build, they expand. Maybe they develop electricity, maybe they don't. Maybe they explore their planet or stay rooted in one continent. Maybe they even look to the stars. Then something happens. A change in climate, a global catastrophe, a slow collapse. Extinction is not rare in Earth's story, it is routine. The civilization ends. Their cities are overgrown, shattered, buried. Their bones are scattered, then dissolved. Within a few million years, most of their story is erased. But not all. That's the key. The Silurian hypothesis doesn't ask us to imagine a perfect fossilized city waiting to be found. It asks us to consider indirect signatures, what scientists call techno-signatures, when searching for alien civilizations. Could a past industrial society leave behind a spike in carbon isotopes or synthetic molecules embedded in ancient sediments? Could it warp the climate in ways detectable tens of millions of years later? Could it scatter rare earth elements or disrupt natural cycles of metals and minerals? There are curious moments in Earth's history, brief spikes in global temperature, strange shifts in carbon ratios, unexplained deposits. These could be natural. Almost certainly, they are. Volcanoes erupt, methane bursts from the seafloor, asteroids strike. But the Silurian hypothesis urges us to ask, what if just one of these anomalies isn't? The danger isn't that we'll find ruins of an ancient city. The danger is that we won't, and that we'll assume that means nothing was ever there, that we'll mistake a blank page for an empty one. The deeper you go into geological time, the more the past becomes a suggestion, a murmur, a whisper in the rocks. And perhaps most chilling of all is this. The thought experiment loops back onto us. If an advanced species had risen and fallen before us, unrecorded and unrecalled, then what does that say about us now? If they left so little behind, what will we leave? What will the Earth remember of us in 10 million years, in 50? If a future species were to dig through our age, would they find our skyscrapers or our satellites? Or would they find only a thin, strange line in the sediment, a layer rich in plastic fragments, carbon soot, and artificial fertilizers, a brief geochemical scar, a civilization compressed into dust and isotopes? This is why the Silurian hypothesis matters, not because it insists on an ancient civilization, but because it sharpens our ability to see. It trains us to look not for obvious answers, but for faint, fragile signals. It reminds us that absence is not proof, that time is not a gentle archivist, and that history is not always written in stone. Sometimes it is written in silence. Somewhere, under miles of rock, may lie the last sigh of a world we never knew. Not a skeleton, not a ruin, just a ripple in chemistry, a layer out of place, a puzzle piece that doesn't quite fit, or maybe not even that. Maybe only the question itself remains, buried in the stone, waiting for us to learn how to listen. Time is a quiet destroyer. It wears down the hardest mountains and buries entire oceans beneath shifting crust. Given enough of it, even the most enduring materials dissolve, fragment, or are drawn back into the mantle like forgotten thoughts. This is the challenge that haunts any attempt to peer deeply into Earth's past. If a civilization once thrived here long before us, long before mammals ruled the surface, what would survive? What could possibly last through the endless churn of geologic time? 100 million years is an unimaginable span. The continents have changed shape. Oceans have opened and closed. Forests have turned to deserts, and deserts to seafloors. Nothing on Earth has remained untouched. In that time, even the bones of dinosaurs have become rare, scattered, and mostly erased. Most of the life that has ever existed is gone without a trace. So what chance would a city have? A machine? A signal? The Earth's surface is not a fixed canvas. It is alive with motion. Tectonic plates grind and slide past one another like ancient gears. The oceanic crust is slowly created at mid-ocean ridges and destroyed at subduction zones, pulled under and melted back into magma. Most of the seafloor is younger than the dinosaurs. Even land is not safe. Mountains rise, then erode to plains. Rivers shift course. Glaciers scrape the land like blades. Every moment, the surface is rearranging itself, quietly but relentlessly. Entropy, too, plays its part. It is not a force like gravity or magnetism. It is a principle, a law written into the fabric of reality. Everything falls apart. Complex systems decay, materials degrade, heat spreads, entropy does not sleep. Steel rusts, glass shatters, concrete crumbles. Plastics, thought to be nearly eternal, break down under ultraviolet light and microbial assault. Radiation slowly alters molecular structures. Even if something were carefully buried, sealed away from wind and rain, time itself would continue the slow unmaking. So what would endure? Perhaps not the objects, but their chemical shadows. Certain molecules could linger in sediment, industrial byproducts, artificial compounds, and synthetic isotopes. These might not be obvious to the eye, but detectable in trace amounts with the right tools. A layer of strange metals, a shift in carbon signatures, a spike in temperature locked into the shells of long-dead plankton. Earth remembers through chemistry, even when it forgets through stone. A civilization like ours, built on fossil fuels, mining, agriculture, plastic, and pollution, would leave a fingerprint, even if its structures are gone. Future geologists might notice a sudden change in sediment, a narrow band rich in unusual elements. They might find mercury, concentrations, transuranic isotopes, or microplastics fused into rock. These signals already exist in our time and will persist for millions of years. But would they recognize them as evidence of intelligence, or simply another natural anomaly? Now imagine that these signals did not come from us, but from someone else. Long before primates, long before flowering plants. Perhaps not even mammals existed yet. A different species with a different path. They might not have used plastic. They might have favored stone, or glass, or materials we would not recognize as artificial. They might have tapped geothermal energy or mastered chemistry in ways unfamiliar to us. And if they collapsed, their markers would be buried, scattered, almost indistinguishable from the background noise of Earth's chaotic history. Some things do last, but they are rare. Zircon crystals, nearly indestructible, can survive billions of years. Some ancient rocks still hold the magnetic imprint of the field as it was when they formed. Deep in Antarctic ice, tiny bubbles trap ancient air. Under the right conditions, fossils can last hundreds of millions of years, though only a fraction of organisms ever fossilize, and even fewer survive unbroken. But fossils require bodies, tools require durable materials, and buildings require time to be covered, not destroyed. A single earthquake or flood can undo what might otherwise have been preserved. Even space does not help. Satellites in low orbit decay within decades. Higher ones last longer, but radiation and micrometeoroids eventually shred them. The moon holds our oldest artifacts, footprints, flags, forgotten equipment, but on Earth, gravity and weather are constant, patient erasers. A thought experiment. If New York City were abandoned today, how long would it last? Within a few centuries, nature would reclaim the surface. Steel would rust, concrete would crack, trees would grow through glass and asphalt. In 10,000 years, almost, nothing would be visible. In a million, only deep subsurface foundations might remain, and even those would be crushed or buried. In 100 million, the area could be underwater, uplifted into mountains, or subducted entirely. The city would be gone, and with it, the memory of its builders. The planet is old. It has had time not just for one civilization, but for many. Yet the deeper we look, the more the past blurs. 100 million years is not like peeling back the pages of a book. It is like trying to reconstruct a melody from the echo of a single note. Clues exist, but they are fragile, scattered, vulnerable to interpretation. And this is what makes the Silurian hypothesis so strange, so compelling. Not because it claims there was someone before us, but because it exposes how easily that story could be lost. We are used to thinking of ourselves as the beginning, the first to rise, to build, to dream. But the earth is not so sentimental. It records what it can and lets the rest be washed away. Perhaps the greatest lesson is not about the past at all, but about the future. If we disappeared, how would we be remembered? Would we leave a monument, or only a layer? Would anyone know we were here? Would anyone wonder? Or would we vanish as easily as those who might have come before, reduced to traces in sediment, anomalies in isotopes, a question buried in stone? When a star dies, it doesn't vanish. It leaves behind ash neutron-dense, glowing, elemental. The death of fire leaves fingerprints. On Earth, the fire of civilization burns differently, through oil and coal, through reactors and factories, through glass towers and power lines that hum quietly until they don't. If an industrial civilization ever rose before ours, it would have carried its own flame, not the flicker of torches, but the blaze of engines. The question is, could the residue of that fire still exist today, long after the flames have gone out? Industrial activity reshapes the world. It doesn't just build, it transforms. Forests are turned to fields, hills are carved down, rivers are redirected. The atmosphere thickens with gases that weren't there before. The soil accumulates metals in concentrations never found in nature. These are not the kind of traces the wind erases. They settle, they soak in, they linger in the record like scars on skin, deep under the surface, waiting to be found. Burning fossil fuels changes the isotopic makeup of the planet. Carbon comes in different forms, light and heavy, natural and altered. When coal and oil are combusted, they release vast quantities of ancient carbon, pushing a distinct signature into the air and into the oceans. This carbon doesn't just vanish. It is absorbed into shells, locked into sediments, written into the chemistry of future rocks. Paleontologists today can detect subtle shifts in ancient carbon levels and use them to reconstruct events like volcanic outbursts or climate transitions. An industrial civilization, using hydrocarbons at scale, would leave its own chemical spike, a sudden, global fingerprint that doesn't match natural patterns. There is precedent. Roughly 56 million years ago, the Earth experienced a mysterious warming event, the Paleocene-Eocene thermal maximum. Temperatures spiked, carbon levels soared, oceans acidified. Some scientists believe this event was caused by a massive methane release from the seafloor or a burst of volcanic activity under thick carbon deposits. But the isotopic shift is sharp, abrupt, and, in some ways, similar to what we see happening today. The Silurian hypothesis doesn't claim this event was artificial, but it asks, pointedly, if it had been caused by industry, how would we know? Beyond isotopes, there are materials, things that nature does not create on its own. Industrial chemistry has gifted the Earth with substances never before seen: polychlorinated biphenyls, synthetic fertilizers, persistent organic pollutants. Plastics, once thought to last forever, degrade faster than we imagined on the surface, but in the low oxygen depths of oceans or sealed within sediment, they can persist for tens of thousands, even millions of years. Already, geologists have begun finding plastiglomerates, rocks fused with melted plastic fragments forming along beaches. These hybrid materials could fossilize, preserved like amber, becoming strange artifacts of a moment in time. Heavy metals concentrate in industrial zones. Mining, manufacturing, and waste disposal all leave residues. Elevated levels of lead, chromium, cadmium, and rare earth elements can be detected long after the surface infrastructure is gone. These metals settle into soils, wash into riverbeds, accumulate in lake sediments. If civilization collapsed today, future geologists might find these same patterns, a sudden surge of rare compounds appearing at a specific layer, with no clear biological cause. Radioactivity, too, tells a story. Natural uranium deposits exist, but fission products like cesium-137 or plutonium-244 are not found in significant quantities without technological intervention. Nuclear detonations, reactor meltdowns, and radioactive waste sites alter the isotopic ratios in subtle but unmistakable ways. Some isotopes decay quickly, vanishing within centuries. Others linger, their half-lives stretching into millions of years. A previous civilization, if it had split the atom, might leave behind faint radioactive trails embedded in bedrock or trapped within glassy slag. Even the climate itself becomes a marker. Industrial activity doesn't just leave chemical residue, it reshapes the global system. Ice melts, sea levels rise, weather patterns shift. If this has happened before, in some distant age, the geological record would contain the echoes. Ancient floodplains where they shouldn't be, pollen grains from tropical trees in temperate latitudes, sudden die-offs in coral reefs. These are not definitive proofs, but they are breadcrumb signs that something disturbed the balance, even if the hand that caused it is long gone. If industry rose in the deep past, its structures would vanish, but its chemistry would not. There would be no ruins to excavate, no tools to hold, but there might be dust, layers of altered minerals, unnatural alignments in sediment, perhaps even a single molecule buried in ancient clay, out of place and out of time. Something that doesn't quite belong, something waiting for the right pair of eyes to notice. The fossil record is not just bones and shells, it's soot and ash. It's the trace of combustion, the residue of process, fires that burned in engines instead of forests, lights that glowed not with flame, but with electricity drawn from deep time. These are fossils too, fossils of fire, fossils of light, and even if we never find them, the fact that we can imagine them is telling. It means we've begun to see the past not just as what was, but as what might have been. It means we're learning to look sideways at history, to question the clean, linear narrative we've always told ourselves. That humanity rose once, and only once, from the chaos of life, that we are the first, that no one came before. But the earth does not promise to keep our secrets. It simply folds them under, layer by layer, and waits. Somewhere beneath the feet of a future species, be it evolved from what we are or something altogether different, there will be a line in the rocks, thin but global, a narrow seam of sediment that spans continents and ocean floors alike. It may look unremarkable at first glance, just another stratum in a planet shaped by heat and time. But as they dig deeper, they'll find something strange, materials that shouldn't be there, compounds no volcano or meteor could create, ratios of elements skewed from the patterns that came before. This is the Anthropocene layer, the geological fingerprint of us. Our legacy is not marble statues or shining towers. It is not the archives we keep or the satellites we launch. It is what we've left embedded in the earth itself. The signal of our time will be found in plastics, isotopes, and an unmistakable pattern of disruption. Long after our languages are gone, after our cities have dissolved, after our names have been swallowed by the forgetting force of entropy, that layer will remain, silent, waiting. Plastic is one of the most defining artifacts of our era. We mold it, stretch it, throw it away. It is in our oceans, our soils, even the air we breathe. It wraps our food and shelters our tools. It is nearly indestructible in the right conditions, yet fragile in the wrong ones. But buried, sealed away from sunlight and oxygen, plastic persists. It weathers but does not vanish. Already, fragments have settled into marine sediments. Beaches now form plastiglomerates, hybrid stones made from melted polymers fused with sand and shell. These are new rocks, artificial but geologically real. Given enough time, they will fossilize. Future hands may pick one up and wonder at its unnatural sheen, the tangled threads of color running through the stone like veins. Beyond the visible, there are the invisible signatures, shifts in isotopic ratios that betray a global story of combustion and change. Carbon has many forms, and we have altered them. By burning ancient fossil fuels, we have released vast amounts of light carbon into the atmosphere. This changes the balance, making today's air chemically distinct from that of the pre-industrial past. It is a signal measurable in tree rings, coral skeletons, and the bones of living creatures. In the future, geologists will be able to drill a core of ice or sediment and point to a sudden, dramatic shift. This is where we began rewriting the planet's chemistry. Oxygen, too, bears our fingerprints. The burning of fossil fuels consumes oxygen, and though the overall drop is slight, it leaves a detectable trend. Nitrogen levels spike from industrial agriculture. Sulfur falls due to clean air regulations. These subtle changes accumulate in the archive of the Earth, written into peat bogs, lake beds, and the quiet layering of seabeds far from any shore. Then, there are the heavy elements, metals pulled from the deep crust and scattered across the surface. Lead from gasoline, now banned, but still lingering in soils and sediments. Aluminum, once rare on the planet's surface, now produced by the millions of tons. Rare earth elements, essential to electronics and almost absent in nature, now woven into waste streams and landfill layers. To a future archaeologist, these concentrations will be unmistakable. Anomalies that radiate outward from this narrow epoch, an era when a species learned to remake the periodic table in its own image. But perhaps the most haunting signal is radioactive. In the mid-20th century, humanity split the atom. We set off nuclear detonations across deserts and atolls, raining fallout across the globe. Isotopes like cesium-137 and strontium-90, unknown in nature, were born in fire and scattered like ash. Even today, they linger in the soil, in bones, in glacial ice. Some will be detectable for tens of thousands of years. Others, like plutonium-244, will endure for millions. These isotopes are time-stamped. Their decay tells a story of origin and duration. A future geologist could detect them and know, to the year, when they were made. They might not know why. That is the strange melancholy of it. The signal may be clear, but the meaning may be lost. A thin layer of plastic, metal, and isotope might survive, but the reasons behind them, the context, the culture, the choices, might not. There may be no fossils of us, no skeletons laid in clean geological context, no cities preserved in volcanic ash or flash frozen in some perfect glacial trap. There may be only the residue, the aftermath, the layer of strange. From above, a stratigraphic column will show a clean line, sharp, abrupt, and different from everything below it. A boundary. The Earth has had these before. The KT boundary, for example, where the age of dinosaurs ended and the rise of mammals began, is marked by iridium from an asteroid impact. Our layer will be just as sharp. It may one day define an epoch not for its longevity, but for its intensity. A flash of activity, a heat bloom, a transformation. We like to imagine that if we were gone, someone would find what we left behind and understand it, that they would look upon our relics and know us. But time has no obligation to preserve meaning. It only preserves what resists it. The rest is worn away. If something intelligent were to rise again, another species, another time, they would find the clues we've etched into the planet. They would see the layer of strange, the chemistry that doesn't belong, the materials that do not decay. They would know that something happened here, something brief and powerful. They would know the world changed all at once. But whether they would recognize us as the cause, or as a mystery, that remains unknown. The Earth will remember we were here, but it may not remember why. Earth has ended its own stories many times. Whole eras have slipped beneath the surface, erased not with malice, but with indifference. The great extinctions come like punctuation marks in the long sentence of life, some sharp, sudden, and violent, others slow and smothering, like a tide that never recedes. There have been 5 major mass extinctions, and each one tore the planet open in a different way. What we often forget is that something had to cause them, and that something is not always a rock from the sky or a flood of lava. Sometimes the cause is harder to see. Sometimes the silence that follows is louder than any explosion. We are used to looking at mass extinctions as natural disasters, random, external, beyond control. A gamma ray burst, an asteroid impact, supervolcanoes, ice ages. But what if, just once, it wasn't nature alone? What if one of these endings had help? The Silurian hypothesis doesn't claim that an ancient civilization triggered a mass extinction, but it opens the door to wonder if such a civilization had once burned fossil fuels, altered ecosystems, changed the chemistry of the air and oceans. Could their rise have led to a fall large enough to leave a scar in the fossil record? Could they have rewritten the climate, tipping delicate balances until the world they knew could no longer hold them? There is something sobering about how easy it would be. Right now, in our own time, species vanish faster than they can be counted. The oceans warm, coral reefs bleach and crumble. Insects decline without fanfare. Forests retreat or catch fire and don't return. These are not future predictions. These are present facts. And if you stretch that reality over centuries or millennia, it begins to look like the early stages of a mass extinction. If we, without intention, are capable of unraveling biodiversity at this scale, then a civilization before us might have done the same, especially if they rose, peaked, and fell without ever learning how to listen to the system they were part of. Take the Permian extinction, sometimes called the Great Dying. It occurred about 252 million years ago and wiped out over 90% of marine species and 70% of land species. The leading theory is that massive volcanic eruptions in Siberia released vast amounts of carbon dioxide and methane, warming the planet and acidifying the oceans. But the signatures are strangely familiar. Global warming, ocean anoxia, a rapid increase in carbon isotopes. It mirrors our own trajectory in eerie ways. No one suggests that humans or anything like us were responsible. The timeline doesn't allow for it. But the pattern, the mechanism, is one we now understand all too well. Civilization leaves a mark. Civilization shifts the climate. Civilization, unchecked, could become a geologic force strong enough to end an age. And once it ends, once the biosphere collapses into itself, time smooths the surface. The explosion is forgotten, but the crater remains. New species rise to fill the vacuum, not knowing what came before. The few survivors adapt, mutate, become the ancestors of something else entirely. Evolution starts over, using the leftover pieces. It's not a tragedy to the planet, it's just another chapter. But it might be the end of a story we'll never read. There's also the question of absence. After each extinction, the fossil record goes quiet. Fewer species, simpler forms, a sudden drop in complexity followed by a slow, uneven recovery. This is where the traces of civilization, if they existed, might be buried or lost. Buildings, artifacts, and technologies are far less likely to survive global upheaval than a trilobite or a fern. The violence of extinction doesn't preserve, it cleans. It scours the surface clean for what comes next. If an ancient civilization triggered such a collapse, their end would likely be swift and complete. Not with a bang, but with cascading failures, crop failures, ecological crashes, the collapse of food webs, cities abandoned, power grids dark, knowledge hoarded, then forgotten, then irrelevant. The survivors, if any, might return to simpler ways or vanish entirely. The machines would rust, the satellites would fall, the books would decay. In a few million years, only the extinction layer would remain, misattributed or unexplained. The cause would be debated, the civilization never found. It is not a comforting thought, but it is a humbling one. Even now, we see echoes. The current rate of species loss rivals some past extinction events. The causes are not hidden. Deforestation, pollution, overfishing, climate change. These are not accidents. They are byproducts of how we live, of choices made not once but millions of times. If the sixth extinction is underway, and many scientists believe it is, we are both its architects and its archivists. We are building our own layer. And perhaps that is why the Silurian hypothesis feels so unsettling. It doesn't just raise questions about the past, it raises a mirror to the present. If another species ever walked this world, if it lived and built and burned and vanished, it might have seen the same warning signs. It might have ignored them, or been powerless to stop them. And the planet, indifferent to memory, simply began again. Maybe we're not the first. Maybe we're just the latest to learn that intelligence does not guarantee survival. But in the quiet layers beneath the soil, in the chemical echoes of long-dead oceans, in the unnatural balance of elements pressed into stone, there may be hints of a civilization that rose high enough to change the world and fell hard enough to vanish. Not with monuments, but with an absence. Not with bones, but with a silence. Because sometimes, the deepest fossil is the one made not of matter, but of consequence. Rocks remember, but only selectively. They are not journals or time capsules, not archives of every moment that's ever happened. They are survivors of pressure and erosion, of fire and flood, of the great forgetting forces that grind the past into dust. The record they keep is incomplete, fragmented, tilted by time itself. And what they choose to preserve is not always what mattered most. This is the quiet bias of geology, the silence that seeps between layers, the gaps where stories should be. When people say there is no evidence of a past civilization, they usually mean we haven't found a building, a fossil, a tool, a sign, something direct, something human-shaped. But that kind of thinking assumes the Earth keeps a perfect record. It assumes that if something extraordinary happened, the planet would have written it down clearly, neatly, in a place we could read. It assumes history is fair, but the Earth has never been fair. Preservation is a privilege. Fossils are rare, not because life is rare, but because fossilization is a trick of timing and chemistry. The vast majority of all life that has ever lived left no trace behind. It decomposed, dissolved, was eaten or crushed or swept away. Even bones don't always last. They must be buried quickly, kept safe from oxygen, shielded from scavengers and rot. And even then, they can be destroyed by heat, shattered by pressure, folded into mountains, or subducted into magma. The fossil record is not a history of life. It is a history of conditions. Now imagine trying to find traces of a civilization in that record. Not bones, but buildings. Not shells, but circuits. Not teeth or claws, but glass and concrete and metal. These are not materials designed to endure deep time. Even stone, unless buried and sealed, erodes. Even metal, unless protected, corrodes. Plastics degrade under light. Ceramics shatter and scatter. Paper vanishes almost instantly. Memory, unless burned into the crust itself, dissolves. We think of our cities as permanent, but they are not. Remove the people and let nature return, and within centuries most structures are unrecognizable. Within millennia, they are gone, buried, warped, or erased. Within millions of years, they are indistinguishable from geology itself. The deeper the time, the less remains. This is the essence of preservation bias. It doesn't just hide the rare, it hides the fragile, the exposed, the temporary. It favors the underwater, the rapidly buried, the geologically lucky. Entire forests once spanned continents, yet we know them mostly through fossil pollen and carbon shadows. Ecosystems flourished for millions of years and left behind only scattered clues. What chance does a thin stratum of civilization have? Some rocks hold fossils not because they were closer to life, but because they were closer to death in just the right way. sudden flood, an anoxic basin, a volcanic ashfall. These are the accidents that allow memory to fossilize. Civilization, if it once existed, would have to be caught in a moment like that, and even then, only a fraction might survive. A collapsed structure preserved in silt, a melted artifact trapped in volcanic glass, a chemical signal buried under the sea. But if the civilization was short-lived, or coastal, or forest-bound, the odds drop further. If it rose and fell in a place now subducted or eroded, it may be lost entirely. And even if something did survive, there is the question of recognition. Would we know it if we saw it? Strange structures have been found before geometric patterns, linear ridges, curious formations. Most turn out to be natural, the products of erosion or mineral growth or tectonic stress. But what if something artificial had become mineralized? What if a factory floor turned to shale, or a data center melted into slag, or a power grid corroded into patterns that now look like veins in stone? How much ambiguity would we allow before we dismissed it as coincidence? Absence of evidence is not evidence of absence. It is evidence of how narrow our window is, of how selective the planet's memory can be. It reminds us that history is not just what is remembered, but what survives the forgetting. The longer ago something happened, the more silence surrounds it. And silence, when stretched across millions of years, begins to sound like certainty, but it is not. We say there is no sign of ancient civilization because we haven't found one. But how much have we truly looked? How many deep ocean sediments have we scanned for anomalous compounds? How many ancient riverbeds have we cored for synthetic residues? How many out-of-place isotopes have we written off as noise? The world is vast. Time is deeper than we can hold in our minds. The surface of the earth is just that, a surface. Beneath it, folded in rock and pressed into clay, are untold chapters we've yet to read. The silence in the rocks is not a verdict. It's a void, a blank page that may never have been written on, or that was written in ink that time has long since erased. And in that silence, possibility lingers. The possibility that something came before us, something that burned and built and dreamed and fell, something that left only whispers in sediment and anomalies in stone. And perhaps we'll never know. Perhaps the best we can do is listen closely to that silence, to learn how to read the negative space, to recognize that what isn't there may matter as much as what is. That history is not just bones and bricks, but also the shadows they leave behind. In the end, geology is not a book. It's a palimpsest, written, scraped clean, and written over again. 1,000 stories layered upon each other, most of them lost. The rocks remember, but only what they can. The rest is silence. And in that silence, we are left to wonder who else once stood here, asking the same questions, staring at the same stars, leaving behind only the thinnest trace of their time in the world. The earth has a talent for disguises. It reshapes, reclaims, and reimagines everything placed upon it. Mountains rise from sediment, seas turn into stone, rivers forget their banks and carve new paths with time and pressure. What once was artificial can become geological, and what once was structure can become landscape. The line between the built and the born begins to blur the deeper into time we look. It's not that the past hides from us. It's that the earth changes the language in which it's written. Somewhere on this planet, there may be a ridge that was once a road, a linear path etched through rock, now eroded and crumbled, mistaken for a fault line or the remnant of an ancient glacier, not because it looks natural, but because we assume it must be. Our minds are trained to see patterns, but also to fit them into the stories we already believe. And one of those stories says that civilization is recent, and nature is old, and anything shaped before us must be shaped by the earth alone. But sometimes the earth holds on to a shape too precisely. There are places where symmetry seems suspicious. Massive geometric structures beneath the sea, carved steps, and right angles weathered but not quite erased. The Yonaguni Formation off the coast of Japan is one such place. To some, it's a natural formation sandstone, sculpted by tectonic uplift and wave erosion. To others, it resembles a sunken city, its terraces and straight edges too orderly, too deliberate. There is no consensus, no definitive artifact, no inscription to confirm the hand of a builder. Only stone, shaped in ways that hover between the plausible and the impossible. It may be a trick of the eye, or it may be something else. Elsewhere, there are mine shafts, tunnels deep in the earth that hold no clear purpose, that run straighter and deeper than water would have flowed, cut with precision into stone. Some are written off as early human efforts. Others are explained away by natural processes, by lava tubes or erosion. But what if a mine is more than just a hole in the ground? What if it is the last remaining scar of a civilization long gone, a sign of deep ambition of a species that once knew how to extract value from the bones of the planet, just as we do now? Even quarries, if buried and uplifted and eroded over eons, might be mistaken for sinkholes or odd depressions. A city's foundations, flattened and crushed beneath the weight of 1,000 storms, might resemble nothing more than fractured bedrock. The ruins of buildings, collapsed and fossilized, could become indistinguishable from natural outcrops. A dam, broken and overgrown, might seem like a landslide frozen in time. Given enough years, the artificial becomes camouflaged, the unnatural becomes background. There are patterns we dismiss because we think we know what nature looks like. Hexagons in basalt columns, like those at Giant's Causeway, occur through cooling lava. Perfectly round boulders, like the Moeraki in New Zealand, are formed by spherical concretions. Caves carve out cathedral-like spaces. Rivers braid into fractals. Trees draw lightning patterns into wood. Nature is not afraid of geometry, but this complicates things. Because if a machine left a mark, if a road once sliced across a continent, if a tower once fell and was buried, how would we know that it wasn't just another quirk of erosion or uplift or sedimentation? This is the challenge of deep time disguises. Nature mimics design, and design, after enough time, mimics nature. A wall becomes a cliff face, a foundation becomes a fault line, a city becomes a strange formation no one can quite explain. And in that uncertainty, there is room for both skepticism and awe, because some anomalies remain unresolved. Structures beneath ice sheets, grids found deep in the jungle through satellite imaging, ancient maps that hint at coastlines before the last ice age, stories passed down through oral traditions that speak of great fires and floods, of towers swallowed by the sea, of a world that came before the world we know. These are not proofs, but they are echoes. Not all of them will lead somewhere. But to dismiss them outright is to assume we've already found everything worth finding. We often search for civilizations by looking for what we would leave behind. Cities, artifacts, written language, but these things are fragile. They vanish quickly unless preserved in just the right way. What survives longer are disruptions, shifts in the landscape, concentrations of metal, chemical residues, anomalies in the geological pattern. And sometimes, those show up in places we can't explain, not because they don't belong, but because we don't yet know how to read them. The earth is not malicious in its concealment. It simply moves forward. It crumples the past into mountains and scatters it into riverbeds. It does not preserve meaning. It preserves form, and even that imperfectly. If there were once towers made of crystal or carbon or alloys we no longer use, they would not be here now. But their shapes might linger softened, twisted, mistaken for things that never thought, and we, standing on the surface, digging here and there, might not see what they once were. So perhaps the question isn't whether the earth is hiding a lost civilization. The question is whether we're looking with the right eyes, whether we're willing to question the familiar, to wonder at the almost straight line, the out-of-place trench, the too symmetrical ruin, half swallowed by moss. Whether we're willing to hold ambiguity in our hands and admit that the past is not as clean or as knowable as we like to think. Because sometimes The planet wears a mask, and sometimes, buried beneath its oldest disguises, is the memory of something that once stood tall and then fell so completely that even the rocks forgot what it was. The Silurian period was not a time of cities. There were no eyes cast toward the sky, no written language carved into clay or inked onto page. There were no fires harnessed for purpose, no structures raised with tools, no sound of machines humming quietly into the night. And yet, it is from this period over 400 million years ago that the name of a hypothesis was drawn, not because it offers the best evidence, but because it opens a door. It gives us a place to start imagining what might be possible, even in the most unlikely corners of time. Back then, the continents were adrift in unfamiliar shapes. Vast stretches of shallow seas flooded inland, painting the world in blue and green. Life was in the middle of a slow but staggering transformation. On land, the first true forests were beginning to take hold. Small vascular plants pushing up from the soil, reaching towards sunlight that had never before touched leaves. In the oceans, early fish had begun to develop jaws, and trilobites still scuttled along the seabed, their armored forms a reminder of life's long memory. It was a time of transition, quiet on the surface but monumental in its implications. It was also a time long before dinosaurs, long before mammals, long before the great extinction events that would sweep the planet clean again and again. The Silurian is ancient even by Earth's ancient standards. 400 million years is enough time to lift mountains and wear them flat again. Enough time to erase continents, to hide oceans beneath new crust, to bury anything delicate beneath miles of pressure and silence. It is not chosen because it is likely. It is chosen because it is deep, because it reminds us how far back the past truly goes. The name Silurian hypothesis comes from fiction first, not fact. In a 1970 episode of Doctor Who, an ancient, intelligent reptilian species is awakened from hibernation, having once ruled the Earth in the time of the dinosaurs. The Silurians, as they were called, became a symbol of pre-human intelligence, alien, but not extraterrestrial. The term was borrowed by real scientists, not to suggest that lizard people once walked the Earth, but to explore a question wrapped in layers of science, skepticism, and possibility. Could a civilization have existed so long ago that we no longer see it? The answer is not a claim. It's a thought experiment. It is not that the Silurian period was likely to harbor intelligent life. It's that if intelligence did rise once before, in any form, at any time, even briefly, would we be able to detect it? Would we know? The further back in time we look, the more the Earth begins to fold in on itself. Rock layers do not remain still. They tilt and twist. Oceans rise and fall. Crust is swallowed at subduction zones, where entire geological chapters are erased without ceremony. What is old is rarely accessible, and what is accessible is rarely old. The Silurian period exists in fragments, a layer here, a formation there, often exposed only in places where the ground has been lifted and scraped by ice or tectonic force. Yet even in these pieces, we see no cities, no roads, no evidence of culture, of machines, of writing or architecture or fire. We see life. Yes, fossils of armored fish, of soft corals, of primitive plants pushing their way onto land for the first time, but nothing that suggests minds like ours once walked the world. The fossil record is quiet. The rocks bear no signatures of industry, no spikes of carbon from combustion, no buried layers of synthetic residue. And still, the hypothesis remains, not because we think the Silurian is where it happened, but because it reminds us that the absence of evidence is not always the evidence of absence, especially in a world that forgets, especially in a planet that recycles its surface with tireless indifference. What the Silurian represents is scale. It represents just how much time Earth has had to work with. long enough for entire epochs to rise and vanish without leaving behind more than a chemical whisper. It's difficult sometimes to hold that kind of time in the mind. We measure lives in decades, cultures in centuries, civilizations in millennia. But deep time is different. It does not care about names or dates or meaning. It is measured in strata, in isotope decay, in the slow drift of continents and the steady build of sediment. And when you realize that our entire recorded history fits inside a blink of Earth's timeline, the possibility of something before us, something ancient, lost, and now untraceable feels less like fantasy and more like humility. The Silurian period is a canvas, not a clue. It is not the place where evidence is hiding. It is a placeholder for all that might have been before what we know. A reminder that Earth has had many chances, that evolution has experimented with countless forms, that intelligence may not be a one-time phenomenon, but a repeating pattern, one that emerges, burns brightly, and then disappears into silence. There may have been nothing. No cities, no machines, no voices speaking across the void of space. Just fish and ferns and the long, slow crawl of life becoming more than it was. That is the likeliest truth. But we look anyway. We ask. Because the absence of artifacts does not mean the absence of story. It means only that we are trying to read a book where most of the pages are missing, where the ink has faded and the paper has been turned to stone. The Silurian hypothesis is not about finding answers. It's about opening a door in the mind. A door that asks, if something came before us, how would we know? What would it leave behind? And would we recognize its traces as different from our own? The rocks may never answer, but the question echoes just the same. Intelligence is not always noisy. It does not always roar into the sky on plumes of fire or build towers that scrape the clouds. It does not have to carve roads, mine metal, or wire itself into a web of satellites and signals. There is a quieter kind of intelligence, one that listens more than it speaks, that adapts without conquering, that lives with the world rather than transforming it beyond recognition. And in imagining the long history of life on this planet, we must ask, could a civilization have existed that never discovered technology as we know it? Could minds have emerged, thoughtful and wise, without ever becoming industrial? The word civilization conjures images of infrastructure, of agriculture, of cities blooming outward in geometric sprawl. We picture kilns and currencies, libraries and laws, the machinery of culture growing ever more complex. But this is only one path, a path we took. It's tempting to believe it was inevitable, that any species with sufficient intellect would end up here eventually, staring at screens, launching probes, leaving footprints on the moon. But inevitability is a trick of hindsight. Evolution is not a straight road. It is a forest of branching paths, most of which lead to endings we never see. What if another species reached awareness, selfhood, reflection, but chose differently, or never needed to choose at all? Imagine a species with intelligence equal to or greater than ours, social, emotional, deeply attuned to its surroundings. Perhaps they lived in the ocean, where fire was never an option and tools were difficult to wield. Or perhaps they lived in dense forests, where resources were abundant and mobility was more valuable than permanence. Their minds evolved to navigate relationships, to understand cycles, to remember migration routes, or the medicinal properties of plants. They might have developed oral traditions richer than any written archive, rituals passed through generations with precision and reverence, songs as history, dance as mathematics, memory as architecture. They would have been invisible to the sediment. No smokestacks, no mining, no combustion engines, or plastic artifacts. Their legacy would not lie in altered carbon ratios or isotopic anomalies, but in the subtle shaping of ecosystems, paths worn into the earth by thousands of returning feet, groves cultivated not with machines but with generational care. If their homes were made of wood, bone, clay, or woven leaves, those would dissolve in time, broken down by fungi, by bacteria, by the very systems they once lived within. Even burial practices, if gentle and natural, would leave no bones for us to find. In deep time, only stone remembers, and they may never have needed stone. We call this kind of intelligence pre-industrial, as if it's a stepping stone towards something more advanced. But that's a human story. It's possible to imagine a civilization that valued sustainability over expansion, harmony over progress, one that understood its place in the web and never tried to rewrite it. They may have seen what we did not, that building higher is not always rising. Our species was shaped by scarcity and adversity. We built tools because we had to. Fire kept us warm. Spears brought food. Later, machines magnified our reach, allowing us to reshape landscapes and split atoms. But our path came with costs, forests razed, rivers dammed, atmospheres altered. Intelligence made us powerful, but not always wise. A different species, with a different origin, might have paired their cognition with restraint, not out of lack, but out of choice. We might never find them, not because they were primitive, but because they were gentle. In our search for intelligent life on Earth or beyond, we often look for mirrors, cities, signals, structures, something that reflects our own development back at us. But perhaps we should be listening for different echoes. Perhaps intelligence does not always strive to leave a mark. Perhaps it sometimes seeks to erase its own footprints, to vanish into the rhythms of the world like a bird's shadow on water. Could such a civilization have existed here millions of years ago? The fossil record would struggle to tell us. Even with all our technology, we overlook recent indigenous knowledge systems that carry wisdom older than writing. Oral traditions from cultures that lived with the land, not over it, often go unrecognized by academic models of civilization. And those traditions are still alive. How much more easily, then, could an ancient, delicate society have vanished without a trace? And yet, their intelligence might still echo in the balance of ecosystems they nurtured, in the distribution of species, in the sudden absence of certain predators, or the flourishing of specific plants. But teasing out those fingerprints is difficult. We're only beginning to understand how deeply human hands have shaped the biosphere in just a few thousand years. To detect such subtle influence across deep time would be like trying to hear a whisper through the roar of shifting continents. Still, the possibility humbles. It reminds us that we may not be the first to wonder, to feel, to look up at the stars and ask what else is out there or what came before. A civilization without technology would not have launched rockets, but they may have mapped the stars. They may have seen the same constellations, drawn different stories in them, passed those stories through generations until they became prayers, poems, lullabies. They may have charted the movements of animals, the flowering of plants, the rhythms of weather and wind. They may have understood things we've forgotten: how to live in equilibrium, how to listen instead of conquer, how to disappear without damage. Perhaps the only real difference is that we shouted and they whispered. And in a world that tends to remember only the loudest voices, we may never hear them. But they may have lived for thousands of years in peace and in brilliance, never needing to change the world to feel at home in it. Not every story ends in a monument. Some end in silence. Some end without ending at all, absorbed gently back into the pulse of the planet. If a civilization like that once lived here, we may never know. But the absence of smoke does not mean there was never fire. Not everything disappears. Even in the slow churning of deep time, some fingerprints remain. The earth forgets, yes, but not entirely. It buries, it melts, it grinds. But beneath that relentless erosion, some things resist. Not the grand gestures, not the towers or the tools or the written words. Those crumble quickly, swallowed by rain, root, and rust. But subtle clues linger. Changes in chemistry, shifts in sediment, traces left not in shape, but in substance. And if there was once another civilization, one that burned and built and mined and moved, we must ask, What would they leave behind? Begin with metals. Not the obvious ones, like iron or copper, which corrode and blend into the background noise of geology, but the rare ones. The ones that don't occur in high concentrations naturally. The ones we dig for obsessively: platinum, palladium, neodymium, and europium. These don't vanish, they migrate. They accumulate in specific places: landfills, circuit boards, and catalytic converters. Over millennia, as structures rot away, these elements sink into the soil, wash into riverbeds, settle in lakes. They become part of the Earth's chemical archive. And if you were to drill into a core sample and find an unusually high concentration of rare earth metals, out of step with the surrounding layers, it might not just be an oddity. It might be a whisper of technology. Now consider isotopes. Every material on Earth carries a signature, its own ratio of elements, a balance struck by time and physics. But industry disturbs those balances. The burning of fossil fuels, for example, alters the carbon cycle. It leaves behind a distinct marker, a drop in the ratio of carbon 13 to carbon 12. Nuclear activity adds more. The detonation of atomic bombs, for instance, released specific isotopes like cesium-137 and plutonium-239 that do not exist naturally in significant quantities. These decay over predictable timescales, meaning they wouldn't survive tens of millions of years, but their decay products might. And so too might other industrial byproducts: altered lead ratios, shifted sulfur signatures, anomalies in oxygen isotopes, signs that something once intervened in the planet's chemistry. Even plastics, as fragile as they are, have a story to tell. Most break down quickly in sunlight, in oxygen, in time. But buried in the right conditions in landfills, in ocean trenches, beneath layers of sediment, they can persist, not as bottles or bags, but as microplastics embedded in rock. Some even fuse with other materials to form a new kind of stone, plastiglomerate. These are geological novelties, unmistakably artificial, capable of surviving if sealed away from the surface. A future geologist, encountering such a rock without context, might puzzle over its origin. It doesn't look like any natural mineral. Its polymers are not formed through volcanic or biological processes. It's a clue, out of place and out of time. Then there are the sediments themselves. Civilization reshapes the land. It levels forests, redirects rivers, flattens hills, builds harbors. And each of these actions leaves behind a layer. Soil becomes compressed in unusual ways. Sediment grain sizes shift. Urban dust contains traces of combustion, of construction, of industry. Heavy metals settle in lakes and estuaries, layering like tree rings. In ocean beds, the fallout from pollution and emissions changes the microscopic makeup of the seafloor. Diatoms, tiny algae that build shells from silica, respond to changes in temperature and chemistry. Their fossils reflect these shifts. And so, a civilization may be recorded not in monuments, but in the shells of plankton. We might also find odd absences, fossil layers that should contain diversity, but don't. Sudden declines in species, localized extinctions that coincide with chemical disruptions. A civilization doesn't just leave behind what it builds, it also leaves behind what it breaks. If industrial processes led to the die-off of specific organisms, that gap becomes part of the record. And if these die-offs were sharp enough, global enough, they might register as minor extinction events, periods of rapid turnover, not caused by volcanoes or asteroids, but by industry. Of course, none of these signs are definitive. Each one could have other explanations. A spike in metals could come from a meteorite. Isotopic anomalies might result from volcanic activity. Plastic-like materials could be misidentified. The story of the Earth is full of strange chapters, and not all of them involve us or anyone like us. But when these signs appear, together, in the same layer, they begin to form a pattern, a cluster of anomalies that hint at agency, at a moment when the planet's systems were nudged by something that knew what it was doing. We think of legacy as monuments, as records carved in stone, but stone wears down. What endures are the changes we make without thinking, the ones etched into the chemistry of the world. If there was a civilization long ago, its most lasting mark might not be a city, but a spike in metal, a shimmer of altered isotope ratios, a thin band of unusual sediment laid down quietly beneath the sea. Perhaps we've already seen such a layer. Perhaps it lies buried beneath others we have yet to dig. Perhaps we've dismissed it as a fluke, a curious event not worth deeper inquiry, because we still expect the past to look like us, to leave behind coins or tools or statues. But deep time doesn't work like that. It scrapes away detail, smooths the edges, leaves only residue. In that residue, a ghost might remain. Not the kind that walks or speaks, but one that shifts a graph line or glows faintly under a spectrometer. One that reminds us that change is traceable, even if its source is lost. One that waits quietly in the strata, asking a simple question: did someone come before us? And if they did, is this all they left behind? If we vanished tomorrow, no warning, no farewell, just gone, what would remain of us 1,000,000 years from now? 1,000,000,000? Would the record of our time on Earth be legible to whatever came next, or would it fragment into a puzzle of chemical signatures, fractured ruins, and inexplicable materials? The Anthropocene, the proposed epoch we're carving into the crust with our presence, is still young, but already it hums with echoes, some loud and lasting, others soft and strange. And if another civilization someday sifts through the sediment we leave behind, will they find in it a mirror, or will they find a mystery? Our cities rise high, luminous and sprawling, but they're fragile in the scale of geologic time. Concrete crumbles in decades, steel rusts, glass shatters, and weathers to sand. Our tallest buildings would not last 1,000 years untended. Roads crack and are overtaken by roots. Satellites orbit for a time, then fall, burning away as dust. Even the Great Wall would fade into the hills without human hands to maintain it. In 10,000 years, nature will have reclaimed nearly all visible signs of us. Forests will return. Rivers will redraw boundaries. Earth's slow processes will resume, indifferent and steady. But some things resist erasure. Beneath the soil, deep in landfills and layered sediment, a different kind of evidence accumulates. Plastics, slow to decay, mingle with microfibers and industrial chemicals. Heavy metals from electronics and fuel seep downward, embedding themselves in clay and silt. The residue of combustion, soot and ash, black carbon, settles across wide regions like dark snow, layering with pollen and dust, recording seasons in their stratified order. These are not monuments, but markers. They do not declare their meaning outright, but they whisper it in isotopic shifts, in anomalies, in patterns too precise to be chance. If a future species were to core into the Earth's crust, pulling up a column of compacted history, they might find our echo in a narrow band no thicker than a fingernail. A sudden drop in biodiversity, a spike in carbon dioxide, the presence of synthetic compounds, PCBs, dioxins, long-chain fluorocarbons that do not arise in nature and have no known decay pathway. Traces of nuclear activity, a subtle layer laced with isotopes that could only be made in reactors or weapons. That band, barely noticeable in the sweep of Earth's deep memory, would be unmistakably strange. A rupture, a disruption, a brief but intense event in the grand continuity of life. It would look, from a distance, like a geologic glitch. A future civilization, whether human descendants or something entirely other, would be left to interpret that glitch without context. With our languages gone, our maps dust, our stories lost to rot and silence, they would have to guess at what we were and how we lived. They might wonder at the concentration of plastic particles in ancient oceans, at the disappearance of so many species in such a short span, at the sudden increase in certain metals, cobalt, lithium, rare earths. They might find odd symmetries in the remains of our cities, foundations that line up with cardinal directions, clusters of geometry too intentional to be natural, ruins collapsed and fossilized beneath volcanic ash or sealed in clay. But mostly, they'd find us in the chemistry, because we change the air, the oceans, the soils. Our exhaust lingers in the atmosphere. Our fertilizers alter nitrogen cycles. Our mining activities scatter elements across continents. We have encoded ourselves not in grand, enduring statues, but in the altered balance of the biosphere itself. If intelligence arises again on this planet long after us, it may recognize this fingerprint, not for what it meant, but for how sharply it differs from the rhythms before and after. We often think of extinction as an ending, but in the fossil record, it's just a change in pattern. The trilobites vanish, the ammonites go silent, a dark layer forms, rich in iridium or soot or shocked quartz, and then the world begins again with new players. If we are to become a layer, we'll be a thin one, a strange one, perhaps a tragic one, but not necessarily alone. The question the Silurian hypothesis raises cuts both ways. If a civilization could rise and fall before us and leave almost nothing we can see, then so too could we vanish into the same silence. That's what makes the Anthropocene echo unsettling. It's not only a record of our impact, it's a preview of our impermanence. Everything we are may one day be reduced to a trace in the stone, debated by minds we'll never know. Were we a flash of brilliance or a long mistake? Did we burn too hot too fast? Did we leave behind wisdom or only residue? We won't get to explain ourselves. Perhaps, if those future minds are kind, they will imagine us with nuance. They might see the rise and fall of emissions curves, the spread of agriculture, the arc of innovation and industry, and understand that we were trying, that we were curious, inventive, hopeful, flawed, that we shaped the world in ways both magnificent and disastrous, that we loved and feared and dreamed even as we struggled to see the long view. And if they too become curious about their past, perhaps they will ask the same question we are asking now. Was there someone before us? The silence between civilizations may be vast, but the echoes remain, not in words or images, but in the subtle distortions of the natural order, in the layers that don't quite make sense, in the clues that survive entropy just long enough to spark wonder in someone else. We are not the first to look backward and imagine. We may not be the last to be imagined. 56 million years ago, something happened. It was not loud, at least not at first. No asteroid struck, no mountain exploded. The change came like a fever, slow, rising, inescapable. Across the planet, the oceans warmed, the skies thickened, the forests shifted, and deep in the Earth's record, there lies a line, a spike, a sudden surge in carbon that left its mark in stone, in shells, in the breath of the biosphere itself. Scientists call it the Paleocene-Eocene thermal maximum, the PETM. And while it is framed as an event, a thermal maximum, a moment in time, it is also a question, one still not fully answered. The Earth had already been warm. This was a greenhouse world, lush and humid, where palm trees grew near the poles and crocodiles basked in Arctic rivers. But then came the spike. In just a few thousand years, a blink in geologic terms, temperatures climbed by at least 5 degrees Celsius globally. The oceans became more acidic. Carbon flooded the atmosphere. Deep-sea organisms vanished. Ecosystems scrambled to adapt. Mammals migrated, evolved, took new shapes. Everything moved, changed, reacted to something immense and sudden. But what caused it? That's the mystery. Because the carbon didn't just rise in volume, it changed in flavor. The isotopic ratio shifted dramatically. Specifically, there was a sharp drop in carbon-13, relative to carbon-12. That matters. Carbon-12 is the lighter, more common form, and it's preferred by living things. When plants grow, when organisms breathe, they concentrate carbon-12. So when a sudden flood of light carbon enters the atmosphere, it usually suggests something biological. Something alive or recently dead was burned, released, or disturbed. The leading theories suggest massive volcanic activity, specifically from the North Atlantic igneous province, where lava may have cooked organic-rich sediments and released methane in vast quantities. Another idea points to clathrates, ice-trapped methane buried beneath the seafloor, melting and belching their contents into the sky. Yet others wonder if peatlands caught fire or permafrost thawed, releasing ancient stores of carbon. Each of these scenarios could explain the sudden isotopic shift, the pulse of warmth, the extinction patterns, but none of them are certain. The cause remains blurred, even as the effects are clear. The carbon spike was not subtle. It's visible in core samples pulled from beneath the ocean floor, where layers of ancient mud have recorded the last 60 million years like pages in a hidden diary. In these layers, foraminifera tiny shelled plankton show signs of stress. Some disappear, others shrink. The chemistry of their shells reflects the change in pH, the rising temperatures, and the altered carbon cycle. On land, fossils reveal the migration of species, the shrinking of body sizes, the spread of tropical plants into what had once been temperate zones. The planet was reorganizing itself in real time. It took over 100,000 years for the Earth to stabilize again, for carbon levels to fall, for ecosystems to settle into new patterns. But even then, the world that emerged was not the one that had come before. Evolution had been nudged onto a new path. The primates that would one day become human ancestors diversified during this time. The modern mammalian orders, those we see today, began to take form. In some sense, the pedum cleared the stage, and life, ever adaptive, filled the space that remained. But what if the PETM wasn't just a natural disaster? What if the carbon spike, with its biological signature and global reach, wasn't solely volcanic or tectonic? What if it was an echo of something else, something deliberate? That's the thought the Silurian hypothesis dares to entertain. It doesn't claim certainty, only possibility. It asks, if there had been an industrial civilization before us, one that burned carbon, mined, built, consumed, would we be able to tell? And if we did see the traces, would we even recognize them for what they were? The PETM is one of the few moments in Earth's past that resembles the Anthropocene. It shows a sharp, sustained increase in greenhouse gases, likely driven by the rapid release of carbon from once sequestered stores. It includes a marked change in biodiversity, and it leaves behind a distinct geochemical fingerprint. It's natural to ask whether these signatures align too closely with what we are doing now, or whether the resemblance is merely illusion, a trick of converging processes. If a civilization had existed 56 million years ago and burned fossil fuels at a scale anything like ours, it could potentially leave behind the same carbon isotopic signal, the same warming, the same ecological disruption. But would it also leave behind other signs, plastics, metal concentrations, altered sediment layers? We don't know. The deeper we go in time, the more those delicate indicators are scrubbed away. The ocean floor is constantly renewed, the continents eroded and reshaped. In the record we can still access, much has already vanished. So the pedum lingers as a tantalizing enigma. Perhaps it was only methane, only volcanoes, only the chaotic breath of a living, changing planet. But perhaps it was more, not proof of an ancient intelligence, but a moment that rhymes too closely with our own to ignore. A mirror tilted back through time. If we are causing a similar spike now, and we are, then we are writing our own chapter in the same hidden book. Our combustion, our emissions, our reshaping of the world will leave a line just like the one at the PETM. Future beings, if they arise, may study it the way we study that older spike. They may wonder what triggered it, what it meant, who we were. And perhaps, if they also find the PETM, they'll ask the same question twice. Once for us, and once for whoever or whatever might have come before. The earth has a memory, but not one of names or faces. It remembers in chemistry, in the buried layers of ancient oceans, in the powdered dust of long-forgotten deserts, in the sediments that quietly stack themselves over centuries like pages in a deepening book. It records the story of change, not always with clarity, but with persistence. Across those layers are whispers of catastrophes, of volcanoes and impacts, and sudden die-offs. But here and there, scattered like static in the fossil rhythm, are signals stranger still, chemical shifts that don't align neatly with the usual suspects, ratios that look altered, compounds that don't fit. And though science has explanations for most, a few remain uncertain, open to interpretation, open to possibility. Take, for instance, the curious case of lead. In modern times, we've scattered it across the globe. From gasoline, from paint, from industry, a fingerprint of the 20th century now embedded in ice cores, soils, and seabeds alike. But lead isn't a silent passenger. Its isotopes carry a signature, a precise ratio of variance that can suggest origin, natural ore, industrial refinement, or atmospheric dispersal. When archaeologists study ancient civilizations, they often trace human movement and trade by these isotopic signatures, mapping where metals were mined and how they were used. On a larger scale, geologists do the same with Earth's older layers, and sometimes they find concentrations of lead, copper, or zinc that seem unusually pure, unexpectedly localized, or oddly structured for entirely natural causes. Then there are the polycyclic aromatic hydrocarbons, or PAHs. These molecules are born in combustion. Forest fires, yes, but also engines, furnaces, industrial smokestacks. They linger in sediments long after the flames have gone out, their chemical resilience allowing them to endure where other compounds break apart. In some parts of the rock record, sudden spikes in PAHs appear rapid increases, not tied to known wildfires or volcanic events. We assume natural causes because natural causes are what we know. But there is a difference between assumption and certainty, a pause between what fits and what's possible. Mercury, too, shows strange behavior. Often linked to volcanic eruptions, its concentration in sediment can signal periods of intense geological upheaval. But mercury also accumulates from industrial processes. It's released by burning coal, by smelting metals, by manufacturing. In modern cores, those that sample lake beds and ocean floors, we see its steady rise since the dawn of the Industrial Revolution, a curve now so familiar it's used as a marker of human impact. In the deeper past, spikes in mercury are typically assigned to flood basalt events, like those thought to have contributed to mass extinctions. But what if, in some layer, one of those spikes doesn't quite match the volcanic pattern? What if the mercury is there, but not the ash? What if the ratio of companion elements is just slightly off? Science, cautious by nature, offers models and margins. It leans toward the simplest answer, the most probable cause. But when the Silurian hypothesis enters the conversation, it asks us to consider a different lens, to wonder not just about how these anomalies came to be, but whether all of them must be natural, whether it's possible that one, just one, is not. There's a layer in the geologic column, the boundary between the Devonian and Carboniferous periods, where oxygen levels suddenly rise. The fossil record shows an explosion in plant matter, in insect size, in swampy ecosystems teeming with life. It's explained by the vast colonization of land by forests, an entirely plausible, entirely natural process. But oxygen doesn't rise alone. It brings with it changes in carbon storage, in erosion rates, in atmospheric chemistry. Could a civilization hypothetically have contributed to this shift, not necessarily by burning fuel, but by altering the land-clearing space, changing ecosystems, modifying flow. We don't know. The signal is smeared by time, the layers thinned, eroded, overlain by more dramatic events. In Antarctica and Greenland, ice cores reveal layers of dust and sulfate that align with historical volcanic eruptions. Pinatubo, Tambora, Krakatoa. But even these detailed records only stretch back hundreds of thousands of years. Beyond that, the evidence becomes more subtle, more scattered. In ocean sediments, anomalies in barium or strontium sometimes appear elements that don't float freely, but bind to certain processes. Could a spike in barium suggest drilling, mining, waste, or is it simply a local mineral influx, never meant to mean anything more? The danger in all this is apophenia, seeing patterns where none exist. But the greater danger may be its opposite, ignoring patterns that do exist simply because they don't fit a familiar story. The Silurian hypothesis isn't an answer. It's a prompt, a way of holding up the chemical archive and asking, gently but insistently, what else might be true. If a civilization existed millions of years ago, we should not expect to find its monuments. We should not expect tools or bones or books. We should expect residue, elements that are out of place, ratios that are subtly wrong, compounds that require temperatures or conditions not known in nature. We should expect confusion, doubt, debate. And we do find those things, not in abundance, not enough to rewrite history, but enough to raise a quiet eyebrow. Perhaps the truth is simple. Volcanoes erupted, forests burned, oceans turned over. Life evolved. But if even one anomaly turns out to be more than that, if even one spike, one ratio, one chemical ghost is a relic of choice, not chance, then the story of Earth grows larger. Not every clue will lead to revelation, but the sediment is speaking, and it does not always say what we expect. Life has always been an architect, but its blueprints are strange, sprawling, and slow. Unlike the quick precision of human hands, biological design unfolds over eons, not hours. It builds not with bricks or steel, but with root systems, feedback loops, and chemical whispers. The very shape of our planet, its breathable air, its deep oceans, its gentle temperatures, is not an accident of geology alone. It's the result of life reshaping its own habitat, again and again, across billions of years. And sometimes, when we step back far enough, the transformations are so vast, so deliberate seeming, they begin to resemble something else entirely. They begin to resemble intention, not in the way we usually define it, no architects sketching plans, no meetings of minds, but something quieter. Systems that adapt and respond, networks that reinforce favorable conditions, cycles that self-correct, a biosphere behaving almost like a mind. This is not metaphor. It's Gaia theory, proposed decades ago by James Lovelock and Lynn Margulis, and once dismissed as mysticism, but now regarded with growing curiosity. The idea that Earth behaves like a single living system, one that regulates itself to support life. But what if, somewhere in that long story, life did more than adapt? What if it engineered? Look to the Great Oxygenation Event, more than 2 billion years ago. Cyanobacteria, simple and ancient, began releasing oxygen through photosynthesis. For them, it was waste. For the planet, it was revolution. Oxygen flooded the seas, then the sky. It killed off most of the anaerobic life that had dominated until then. A mass extinction, triggered not by asteroid or fire, but by microbial breath. In time, oxygen would enable complex life, multicellular organisms, nervous systems, eventually, us. But none of it was planned. It was a side effect, a byproduct. Life had reshaped the atmosphere, not knowing it would become its own foundation. And yet, what if that process wasn't entirely blind? It's here the Silurian hypothesis bends toward its strangest implication. If a species arose in the distant past not like us in form, but but equal in thought. What if its impact looked nothing like what we expect? What if it didn't build cities or engines? What if it shaped the world from the inside out? Intelligent design doesn't have to mean factories and satellites. It could mean gene editing, ecosystem engineering, terraforming not with machines, but with microbes. A civilization that turned its understanding inward, changing life itself to change the planet. If they succeeded, their legacy might not be metal or plastic or ruins, but entire biomes. Forests that optimize climate regulation, algae that tune carbon cycles, fungi that break down toxins or sequester minerals, life forms that seem natural because they've always been here, but are, in truth, legacy systems, living artifacts. We already do this in the smallest ways: genetically modified crops, bacteria engineered to digest oil spills, projects to seed clouds or restore reefs. But these efforts are clumsy, early, limited. We stand at the edge of the idea. What lies further in? If a past civilization reached that edge and stepped beyond, how would we know? What markers would survive? DNA mutates, organisms go extinct, climate changes, wiping clean the benefits of old balances. But some traits persist for astonishing spans. Some lineages are remarkably stable. Horseshoe crabs, ferns, sharks. Are they echoes of an untouched lineage, or of a design that worked too well to vanish? The sediment does not preserve intent. Rocks cannot say whether a genetic shift was random or engineered. But patterns emerge, genes that appear suddenly, without clear precursors. Symbiotic systems that seem too perfectly tuned, coevolution that aligns so precisely it borders on improbable. These are not proof, but they are questions. Consider the soil, rich, dark, full of life. Its structure is a complex symphony of minerals, microbes, moisture, and decay. In the Amazon, large regions of soil known as terra preta, dark earth, are vastly more fertile than surrounding lands. They contain charcoal, broken pottery, and other remnants, suggesting human modification. But their scale, longevity, and persistence hint at something more, a kind of ecological engineering, not industrial, not mechanical, but powerful, and in some cases, hard to distinguish from nature itself. Now extend that concept not thousands, but millions of years back. Imagine a species that understood the biosphere not as a resource, but as a programmable system, one whose climate, chemistry, and resilience could be shaped without machines. Their cities might have been forests, their monuments, ecosystems, their power grid, a planet humming in balance. And when they were gone by choice or chance, their tools would dissolve into the living systems they built. No ruins, no smoke, only balance, for a while, until entropy resumed its course. We assume that technology must always mean metal, that intelligence must shout to be heard. But what if it whispers instead? What if the greatest accomplishments of a past species are not visible in what they added to the world, but in what they stabilized, corrected, or guided? What if they prevented a disaster, tuned a cycle, healed a wound so far in the past that we can only see the scar? Maybe that's all we'll ever find. A planet that once tilted toward chaos, and then subtly, strangely, didn't. A climate that rebounded faster than models predict. A system that behaves, now and then, as if it remembers something it shouldn't. Terraforming isn't always terraforming. It doesn't need flags or domes or drills. Sometimes it's quiet, embedded, forgotten even by those who benefit from it. It's what we're beginning to attempt now, with carbon capture, rewilding, to synthetic biology. We're trying to undo damage, to stabilize what we destabilized. And if we succeed, our descendants may never know how bad it almost became, or how deliberate the recovery was. If someone had done the same long ago, would we know? Or would we live atop their legacy, calling it nature, unaware we are breathing the air they left us. Intelligence does not require hands. It does not require fire. It does not need to walk upright beneath a sunlit sky. That is merely the shape it took with us. But life, shaped by pressure and chemistry, has always been willing to try other forms. In the deep, where sunlight fades and pressure grows, there are eyes that see without light. In the skies, wings stretch across thermals older than memory. Thought does not belong to any one form. It waits for the right conditions, then blooms where it can. The ocean has always been a cradle for the strange. In its silence, it shelters minds we still struggle to measure. Cephalopods, with their arms of independent memory, solve puzzles with elegance and speed. They mimic, deceive, escape, adapt. Their brains are decentralized, their skin reads light. They live short lives, and yet in that time show a fluid, alien cleverness that hints at something deeper. Not human, not primitive, simply other. We consider them intelligent, but not civilizational. They do not build, they do not write. But perhaps that is not failure. Perhaps it is choice or constraint. Without fire, metallurgy is impossible. Without dry land, electricity is unlikely. But what if intelligence, free of our limitations and desires, took another path entirely? One that didn't need cities or computers to flourish? One that evolved in a place where permanence is rare, where the tides erase every mark? A civilization of the sea might leave no ruins. It might communicate through bioluminescence or complex songs, pass through water rather than air. It could encode memory in living tissue, use genetic information as archive, or manipulate currents and reef structures to shape its environment. Its tools might be organic. Its records might die with each generation, but leave influence behind in altered species, tuned ecosystems, strange bursts of coordinated evolution. We might never recognize it as a civilization at all. Above, the skies offer a different kind of mystery. Birds are descended from dinosaurs, and their brains, once thought primitive, are now known to perform complex calculations, tool-making, social coordination. Corvids hold grudges, gift objects, plan for the future. Parrots name each other with sounds, pass language between generations. A mind in the air lives by different rules than a mind on the ground. It remembers distances. It reads the land as pattern, not place. It lives lighter, faster, with less to carry and more to lose. Could a skybound species have reached intelligence long ago? Not the kind that paves roads, but the kind that understands migration like mathematics, weather like memory, a civilization of wind and instinct. Their legacy would not be metal or stone, but perhaps sudden changes in seed distribution, in forest structure, in the patterns of pollination. If their tools were beaks and feathers, their temples might have been cliff faces, their libraries the sky itself. And when they vanished, it would have been as quiet as their passing shadows. It is hard to imagine minds so unlike ours. We are biased toward mirrors, toward creatures that walk and grasp and speak aloud. But intelligence may not need to speak. It may not need tools. It may not even need continuity in the way we understand it. It may flare up in brief civilizations, flashes of coordination and culture that burn hot and vanish, leaving behind only hints in biology or geology, clues that blur into the background noise of evolution. And perhaps some minds looked out not upward, like us, but outward into the fabric of their world and chose not to build, not because they couldn't, but because they saw the cost. To mine is to scar. To burn is to warm, to build is to break. What if the first intelligent species was wise before it was ambitious? What if it reached understanding and instead of transforming the world, chose to tread softly upon it? Their evidence would be nearly invisible, not in what they changed, but in what they protected. A sudden halt in extinctions, a stabilization of temperature, an unexplained stasis in a planet otherwise known for chaos. The planet might seem to pause, to hold its breath. We might mistake it for a lull, a quiet interval between great cataclysms, but perhaps it was a time of gentle stewardship, of intelligence that chose not to dominate, but to endure. We are only just beginning to understand how many forms intelligence might take. The octopus in its reef, the raven in its tree, the dolphin weaving sound through water. These are not prototypes. They are not failed versions of us. They are branches of possibility, each carrying a part of the riddle. Some paths diverge and end. Others spiral in silence, unseen by the fossil record. Intelligence may have bloomed and vanished many times before us, each time different, each time incomplete in our eyes, because we are looking for echoes of ourselves. But the Silurian hypothesis asks us to let go of that mirror, to look for signs not of us, but of mind itself, wherever it might have found purchase. To imagine a civilization not of tools, but of patterns, not of monuments, but of relationships. To search for intelligence not in the ground beneath us, but in the rhythms of Earth itself. A planet can hold many secrets. Not all of them are built from stone. Some are folded into the flight of birds, the call of whales, the coral's slow construction of empire. And if they were ever here, if a mind once watched this same moon rise over the same tides, we may never find its cities. But we might still feel its trace, in a world that, for a time, seemed more alive than usual, more balanced, more held. We have always imagined aliens as distant, as visitors from the stars, carried on beams of light, or encased in metal ships older than our solar system. We expect them to be obvious in their otherness, strange anatomies, strange languages, strange machines. But perhaps the greatest alien is not light years away. Perhaps it is underfoot, or within us, or buried so deeply in the past that we no longer recognize it as foreign. We search the skies for civilizations, for structures and signals, for anything that breaks the cosmic silence. But there is another silence here on Earth, older, more complete, and we rarely ask what it means. The search for extraterrestrial intelligence, or SETI, rests on the assumption that intelligent life leaves traces, radio waves, megastructures, artificial chemicals, but in the silence of deep time, we confront a mirror to that same question. If we vanished, what would remain? If something came before us, how would we know? The logic is the same. The challenge is scale. Carl Sagan once wrote, "Absence of evidence is not evidence of absence. In the stars, that comforts us. It means we have not looked long enough, or in the right way. But on Earth, where we can touch and dig and measure, that same phrase becomes more unsettling. If no evidence of ancient intelligence remains here, is it because there was none, or because it was erased too well? We assume a kind of clarity in our own world, that we understand it, that the alien is elsewhere. But Earth is filled with strangeness, with evolutionary dead ends, genetic mysteries, and ancient events that resist explanation. The Cambrian explosion, when complex life erupted seemingly overnight. The Permian extinction, which nearly ended it. The sudden jumps in complexity, in behavior, in adaptation. Some of them make sense in hindsight. Others still hum with unanswered questions. We look at those gaps and think only of what came after. But what if some of them were gaps in memory, not evolution? What if something intervened, or altered the trajectory of life in ways we cannot distinguish from nature? In SETI, we talk of technosignatures, the fingerprints of advanced civilizations, waste heat, artificial isotopes, complex structures. But what are Earth's technosignatures? The Anthropocene layer is one, a mix of plastics, aluminum, radiation, soot, and carbon isotopes unlike anything in the geologic record. A layer so distinct that if someone found it 100 million years from now, they would know something intelligent had changed the world. But earlier layers carry mysteries too. Carbon spikes without clear cause, unusual metal deposits, isotope ratios that strain the usual explanations. These are often written off as volcanism, as asteroid impacts, as natural cycles gone wild. And perhaps they are, but we only ever ask if they are natural or accidental. We never ask if they are designed. It is a taboo question in science. To ask is to risk being mistaken for the pseudoscientist, the conspiracist, the dreamer. But the Silurian hypothesis does not claim that such a civilization existed. It simply asks if the absence of evidence is sufficient to rule it out, and in doing so, it aligns with a growing awareness that Earth may not be as familiar as we think. There are forms of intelligence we barely understand, mycelial networks that span miles and carry information, whale songs that travel entire oceans, bacterial colonies that communicate chemically, adjusting behavior as if part of a larger body. These systems do not build machines, but they process data, they solve problems, they learn. We are only just beginning to consider that intelligence may not require a brain. And if that is true now, it could have been true before. Alien life may not need to come from space. It may have risen here, before us. It may have grown, flourished, vanished, and left behind only a world made slightly more hospitable. A few extra oxygen points, a more stable climate, an ecosystem that holds itself together just a little better than it should. This isn't proof. It isn't even a theory. It is a posture, a willingness to see Earth not just as a cradle, but as a question, because if the conditions for intelligence arose once and led to us, there is no reason they could not have arisen before. Intelligence may not be a single summit, reached only now. It may be a series of peaks, many of which are now submerged. The Drake equation estimates the number of communicative civilizations in our galaxy. It factors in star formation, planet habitability, technological lifespan. But Earth, as a data point, may be misleading. We are the result of billions of years of chance, evolution, disaster, and persistence. We are not guaranteed. We are what happened. And what happened before us might have been something else entirely. We talk of aliens as other, but the real question may be whether we are alone in time, not just in space. And if we're not, if intelligence has emerged before, differently, and died away, then we may already be the aliens of our own world, a species risen from ruins we do not recognize, inheriting a planet that once spoke a language we never learned to hear. In the silence of the stars, we strain for whispers of something more, but Earth too hums with silence, a deep one, and sometimes silence is just what remains after a voice is gone. The Earth does not remember everything. It is not an archive. It is not a careful keeper of records, but something closer to a restless painter, layering new colors over old with no hesitation or sentiment. What survives is not the full story, but fragments, disjointed pieces caught in stone, or trapped in amber, or fossilized by accident. Most of what has ever lived, built, moved, spoken, or burned has vanished without a trace. And for all the grandeur of its scale, Earth is a planet with amnesia. We imagine geology as slow and steady, a process of endless patience. But even slowness has its violence. Continents rise and shatter, oceans spread, then shrink. Mountain ranges are built, folded, and worn down again. Plates shift, burying land beneath land. The surface of the world recycles itself with quiet regularity. Entire terrains, forests, cities, coastlines can be swallowed whole and forgotten. Over millions of years, even the most dramatic scars fade beneath layers of sediment or lava or ice. Some disappear more subtly. Rain and wind erode stone. Rivers carry dust to the sea. Bacteria consume bones. Trees fall and rot and return to soil. Deserts drift and overwrite what came before. If no unusual chemistry preserves the evidence, if no sudden event fossilizes a moment, then nature resumes its endless revision, smoothing the page clean. We call this the preservation bias, the idea that only a tiny fraction of life ever leaves a mark deep enough to last. The fossil record is less a history book than a shattered window, each shard offering a glimpse, never the whole. Most organisms have soft bodies, no shells or bones. Most ecosystems are wetlands, forests, or grasslands, places where decay outpaces fossilization. The ocean floor, which covers most of the planet, is slowly subducted into the mantle every few 100 million years. Even the crust we walk on is not permanent. The oldest rocks are rare and scattered. The oldest soils, nearly non-existent. From the time of the dinosaurs, 99.999% of life left no fossils at all. And yet we construct timelines with confidence, forgetting how much is guesswork supported by the thinnest evidence. Entire epochs are built from a handful of bones or a few chemical traces, and the further back we go, the more the gaps stretch wide. For the first 3 billion years of Earth's history, we have almost nothing in the way of fossils. The deep past is not a museum. It is a field of ghosts. Even within our own history, memory is fragile. The city of Ur, once the heart of a vast Mesopotamian empire, was lost beneath desert sands for thousands of years. The Library of Alexandria burned, and with it, unknown centuries of knowledge. Languages die, stories are forgotten. Even in the age of satellites and global networks, digital records are vulnerable. Formats become obsolete, data degrades, power grids fail. Civilization, it turns out, is only as permanent as the medium it writes itself onto. Now, stretch that fragility across millions of years. Imagine a species rising to intelligence 50 million years ago. Perhaps it lived in coastal rainforests, a region with poor preservation. Perhaps its civilization lasted only a few thousand years, a blink in geological terms before disease or disaster or deliberate exit returned it to silence. If its structures were wood, if its tools were biodegradable, if it built in places that would later be subducted or drowned, then it is possible that nothing remains. Not because it never existed, but because its existence was written in materials not made to last. And yet, we look at the blankness of the ancient record and call it certainty. We assume that because we see no trace, there was no trace to be seen. But the earth forgets more than it remembers. There is a concept in stratigraphy called an unconformity. It marks a gap in the rock record millions of years missing, lost to erosion or non-deposition. These gaps are not rare, they are common, even dominant. In many places, the story of Earth is told more in what is missing than what remains. A smooth boundary where a cliff should be, a sudden shift in sediment, a silence in the stone. Sometimes we find a single fossil embedded in a new layer, with nothing around it for context. It is like finding one sentence from a lost book and trying to reconstruct the plot. Sometimes we find patterns repeating cycles of extinction and recovery, but no cause we can confirm. Climate changes suddenly, oceans turn anoxic, species vanish. We offer theories: volcanoes, asteroids, methane, clathrates. But often, the signatures are too faint, too distorted by time. And sometimes, there are gaps so large that we cannot say what happened at all. The earth forgets, and if a civilization once walked its surface and was later erased, that forgetfulness would be its tomb. It is humbling to realize that even now, with all our knowledge, we are vulnerable to the same forces. We have built taller, faster, stronger, but we remain made of dust. A single global disaster could scatter us. 1,000 years of decay could bury us. And in 10 million years, the Anthropocene layer, our proud footprint, may be compressed to a line a centimeter thick, misinterpreted, or missed entirely. We speak of the past as if we know it, but deep time is a fog. What we see are islands in an ocean of loss. And sometimes, in that fog, we sense the shape of something strange, something that does not quite belong. An isotope anomaly, a pattern in extinction, a fossilized object with no known maker. We dismiss it, more often than not. But perhaps some memories resist forgetting. Not the full story, just an echo, a whisper in the stone, a layer that lingers slightly out of place, a reminder that forgetting is not the same as erasure, and that beneath our feet the earth may be holding on to secrets it no longer knows how to tell. Sometimes, the most extraordinary things are missed not because they're hidden, but because they don't look the way we expect. We search for the strange in the far and the forgotten, but often it sits just outside our frame of reference, quietly misfiled or misunderstood, a tool mistaken for a rock, a pattern dismissed as coincidence, a puzzle piece that doesn't fit any of the pictures we're trying to build, so we set it aside. We like our anomalies rare and tidy, an out-of-place fossil here, a disputed object there, but taken together, these fragments form a strange and persistent whisper running through the background noise of our understanding. Not a declaration, not even a claim, but a question. Could something have come before? And if it had, would we even recognize it? There are places on Earth where the rock itself defies easy explanation. Enormous cut formations in South America, where angles are too precise, lines too clean, and scale too massive to match what we know of the cultures said to have built them. The stones fit together with such tight tolerances that not even a blade of grass can pass between them. And yet the technology required to achieve such things remains speculative at best. We attribute it to craftsmanship, to lost techniques, to time smoothing out the implausible. But every so often, a geologist or engineer pauses, furrows their brow, and wonders if there's more to it. Elsewhere, spherical stone formations dot the jungles of Costa Rica and the hillsides of Bosnia. Some are nearly perfect, heavy as vehicles, and entirely unadorned. Mainstream science leans toward natural formation, concretions shaped over time by the slow layering of minerals. And perhaps that is true, but the sheer regularity of some, and their curious placement in regions far from known geological processes that would explain them, leaves room for doubt. The problem is not proving they're artificial, it's proving they're not, beyond question. Then there are the objects, the so-called out-of-place artifacts, or OOPArts. Many are hoaxes. Some are misunderstood, but a few still gnaw at the margins of plausibility. Tiny metal spheres with grooved ridges found in 2.8 billion-year-old rock. A machined-looking wedge pulled from a Romanian dig in the 1,970 seconds, made of aluminum long before we were supposed to have the means to refine it. A spark plug-like object embedded in geode-like stone. Most are dismissed as misinterpretation, contamination, or outright fraud, and in many cases, rightly so. But even a handful of unsolved examples is enough to fuel the imagination. The scientific process demands skepticism. It demands repeatability, falsifiability, caution. These are the virtues that protect knowledge from fantasy, but every so often, they also become walls. Anomalies are explained away with strained logic or shelved indefinitely, not because we know what they are, but because we cannot afford to entertain what they might be. The fringe is messy. It attracts the speculative, the opportunistic, the pseudo-scientific. But that doesn't mean it's always wrong. Sometimes, the clues may not be objects at all, but disruptions in the layers beneath our feet. Unusual concentrations of rare earth metals, patterns of magnetic disruption in places that shouldn't have any, a layer of fused glass, like the one found in parts of India and Libya, which some have speculated could be the product of intense heat, not unlike the kind generated by nuclear explosions. Geologists attribute these to meteor impacts or lightning strikes, and that may be true. But even still, the patterns linger as questions. Could some ancient force have scarred the earth in ways we're only now beginning to recognize? Language, too, carries its own oddities. Myths of lost civilizations appear across cultures that had no contact with one another. Stories of cities beneath the sea, of knowledge given and then taken, of cataclysms that reset the world. Atlantis is the most famous, but it's not alone. The Hopi tell of previous worlds destroyed by fire and flood. The Sumerians wrote of kings who ruled for tens of thousands of years. Even the Bible hints at a forgotten age of giants, of watchers, of knowledge forbidden or forgotten. These stories are not evidence, but neither are they random. They reflect something deep in the human mind, either a shared psychological inheritance or perhaps echoes of something real, distorted by time and memory into allegory. If a civilization did once rise and fall before ours, its passing might be remembered not in records, but in recurring patterns of story. After all, for most of our own existence, we pass knowledge in myth, not stone. The most unsettling possibility is not that we haven't found evidence, but that we've already found it and simply failed to recognize it. That somewhere in a museum drawer or private collection, an anomalous object sits mislabeled or forgotten. That some unassuming formation in a desert or on the ocean floor is all that remains of a structure unimaginably old. That what we call natural is not, and what we call impossible simply hasn't been understood yet. The world is filled with mystery. Most of it can be explained, if not now, then eventually. But there is a difference between a mystery unsolved and one unexplored. The Silurian hypothesis doesn't argue that an ancient civilization existed. It argues that if it did, we might not know, and that some of what we call anomalies may in fact be tiny truths struggling to survive the weight of assumption. Because not all evidence is dramatic. Not all knowledge declares itself. Some of it waits in plain sight, hoping someone will finally ask the right question. There is something haunting about silence that follows noise, the stillness after a song ends, the dark after fireworks fade. It feels unnatural, not because silence itself is rare, but because once life has declared itself so boldly through light, sound, motion, it feels wrong for it to simply vanish. And yet, that may be exactly what happened. If a civilization came before us, intelligent and powerful, in ways we struggle to imagine, then it also left. The question is not just who they were or how they lived, but why they are gone. Perhaps they destroyed themselves. It is, after all, the shadow trailing every advanced society. The more energy a species harnesses, the more fragile its balance becomes. Power over nature can just as easily be power against it. Maybe they reach the threshold we now approach, the point where tools outpace wisdom, where climate shifts faster than adaptation, where weapons surpass reason and simply lost the gamble. Nuclear fire. Runaway chemistry. A machine that could not be stopped. The end doesn't need to be loud to be final. It can come as a slow erosion, a steady unweaving of systems too complex to repair once broken. And if that happened, what would remain? Not monuments, but residues. Not cities, but layers of ash and isotopes and altered sediment. Signs of sudden change, species vanishing, temperatures spiking, oxygen levels dropping. In the geologic blink of an eye, a civilization could collapse into memory, and then, after some time, even the memory would fail. Erosion and plate tectonics do not care for legacy, but destruction is only one path. Some wonder if they didn't vanish, but left. Not in ships pointed at the stars, necessarily, though that is one possibility, but in ways more abstract. Perhaps they retreated beneath the surface, not in fear, but in purpose. A society that turned inward, away from expansion and toward introspection. A civilization that digitized its consciousness, reducing its material footprint so dramatically that it left no trace, or one that abandoned technology altogether, folding itself gently back into nature in a way we might mistake for extinction. We imagine progress as linear, but intelligence may evolve sideways, even backward, shedding layers like a snake discarding its skin. If they did leave this world physically, as we dream of doing, what would they become? The Earth is not the only cradle of complexity. The moons of Jupiter hold oceans beneath ice. Titan has lakes of methane. Enceladus vents warmth and salt into space. Perhaps they ventured there first, building ecosystems in blackness, adapting to conditions we still consider inhospitable. And beyond that, the stars call with relentless gravity. If they cracked the code of distance wormholes, propulsion beyond light speed, generation ships drifting across gulfs of time, they may have settled in places we have yet to see. Not gone, just elsewhere, and maybe watching. But even this assumes intent. It assumes that intelligence guarantees survival. There is another possibility, quieter and more tragic, that they were erased not by war or wisdom, but by randomness. A comet, unexpected. A supervolcano, too vast to escape. A disease, novel and merciless. Life is resilient, but also fragile, and sometimes the dice roll badly. We tend to forget how many near misses line our own past asteroids that almost struck, pandemics barely contained, solar flares that just missed the mark. Another species, another time, may not have been so lucky, and if they fell that way, then we are not alone only because of their absence. We are here because of it. It's strange to think of intelligence as something that could come and go like a season. We imagine ourselves as the pinnacle, the first and only, as if the universe had been waiting patiently for us to arrive. But the Silurian hypothesis whispers something else, that intelligence may be common, even cyclical, that it rises, burns brightly, and fades, again and again. That consciousness is not a unique flame, but a spark that emerges when conditions allow and disappears when they no longer do. Maybe they left messages, encoded in ways we don't yet understand. Not radio signals or stone carvings, but shifts in DNA, or patterns in cosmic radiation, or anomalies in quantum states. Perhaps we're not meant to find them with telescopes or trowels, but with mathematics and metaphors. Or perhaps they knew better than to leave anything behind at all. Knowing what legacy can become, they chose to let nature close the book cleanly. Because what if memory is a burden? What if the gift of civilization is not permanence, but the chance to begin again? We don't know where they went, or if they ever were. We only know that if they did exist, they are no longer here, not as we are. No bones, no tools, only a few strange readings in the rock, and the nagging sense that something is missing from our story. Not proof, but absence with shape, a hole too deliberate to be empty. So we ask again, not to find them, but to know ourselves, because the answers to their departure are also answers to our future. How long will we last? What will we leave? If silence came for them, will it come for us? And if it does, will someone somewhen ask the same question we ask now? If they were here, where did they go? There is a peculiar kind of déjà vu that doesn't belong to memory. It isn't the feeling that you've been in a place before or spoken a sentence already. It's deeper, stranger, a sense that something larger is playing out again. That history, rather than a straight line, is a spiral, not repeating exactly, but rhyming in tone and tempo. We feel it sometimes in the unease that lingers beneath our progress, a suspicion that we've climbed a mountain without quite knowing what's on the other side, or how many times the climb has happened before. What if the Silurian hypothesis is not just a question about the past, but a warning from it? Not that another civilization once existed, but that ours is simply the latest echo in a very old song, the latest turn of a wheel that has spun many times across the ages. A civilization rises, gathers knowledge, reshapes the earth, leaves behind shadows of its presence, and then disappears, clearing the stage for the next act. Forgotten not because it was small, but because time does not archive everything. It sheds. We assume our moment is unique, that no one has stood at this precipice before, looking out at climate thresholds, planetary boundaries, networks that span the globe. But the earth is old, and it keeps secrets well. If civilizations have risen before, they may have reached similar thresholds, perhaps through different tools, perhaps by different paths, but arriving all the same, at the point where growth begins to fray the fabric that sustains it. The spiral does not need to be perfect. Each turn may look different, one built with stone, another with silicon, a third with something we haven't discovered yet, one ruled by bipedal primates, another by something cold-blooded and silent, still another born beneath the sea. But the pattern, the rise, the reach, the unraveling, could remain constant. We see hints of cycles all around us. In biology, extinction gives rise to innovation. In geology, continents drift apart and collide in endless dance. Even in myth, there are stories of worlds destroyed and remade. The Hopi speak of worlds that came before and ended, leaving only fragments. Hindu cosmology speaks of yugas, great ages rising and falling, with each cycle playing out until it collapses and begins anew. These tales are not science, but they are maps of intuition, echoes of something we may have felt long before we could explain it. If we are part of a cycle, what breaks it? Maybe nothing. Maybe the lesson isn't how to escape the wheel, but how to ride it more gently, to leave less scarring, to become the kind of civilization that is not just forgotten with time, but one that can teach across it. But that too may be part of the cycle. Each version believing it can outwit entropy, each one reaching further than the last before gravity and consequence pulls it back down. There is a strange comfort in the idea that this has all happened before, that we are not the first to ask these questions or to feel that the future is balancing on the edge of a blade. But it is also a responsibility, because if this is a pattern, then we are not just a civilization, we are a test, a new variation, a chance to find out if the cycle is truly unbreakable or merely unlearned. We can't see the past clearly. The rocks are too worn, the records too thin, but the future has not yet been written, and whether it bends toward repetition or reinvention may depend on what we choose to believe is possible. Maybe one day, long after we're gone, a future species will dig through layers of sediment and find us. They'll read the carbon spikes, the isotopic shifts, the plastics fossilized in stone, and wonder. They'll ask the same questions we ask now. Was there someone here before us? Were they like us? And if they were, what happened to them? They'll look to their cities, their tools, their oceans, and ask if they're standing at the same edge or if they're already falling. Could it be us again? The earth doesn't answer. It just turns. There's a certain thrill in imagining ancient civilizations, hidden empires swallowed by time, knowledge buried beneath oceans or stone, cultures so advanced they left no trace recognizable to our eyes. But beneath that thrill, there is something quieter, a whisper of humility. The Silurian hypothesis is not about proving that an ancient species once built cities before us. It's about the unsettling realization that if they had, we might never know. That even something vast, complex, and intelligent can disappear so completely that it leaves behind only questions. That time doesn't just weather stone, it erases certainty. In that way, the Silurian hypothesis isn't just a question about the past, it's a mirror held up to the present. It invites us to consider the scale of our own significance, not in terms of size or power, but duration. We think of ourselves as modern, dominant, secure. We orbit planets. We manipulate atoms. We write code that writes code. And yet, all of it, every satellite, skyscraper, and server farm, is a thin crust atop a planet that has existed for 4.5 billion years. Civilizations, if they existed before, would be as distant from us in time as we are from trilobites, and the Earth would have handled them the same way it handles everything else, slowly, patiently, without bias, turning their works to dust and memory. We know this because we see it happening to ourselves. Cities swallowed by jungle, roads cracked open by roots, ships buried beneath sand. After only a few decades of abandonment, even the mightiest structures begin to dissolve into silence. Multiply that by 1,000,000 years, and it becomes clear how fragile even our most enduring creations really are. This isn't a reason to despair, it's a reason to pause, because the Silurian hypothesis reminds us that permanence is not promised, that to be remembered, we must be understood, and to be understood, we must understand ourselves first. What will we leave behind? Not just physically, though that matters, but narratively. Will we be a species remembered for its vision or its short-sightedness, its compassion or its consumption, its imagination or its insistence that it was the only one? We tend to look upward when we search for intelligence toward the stars, scanning for signals in the static. But the Silurian hypothesis asks us to look down into the Earth itself and realize that the most profound discoveries may not lie beyond us, but beneath us. That the story of life on this planet may be stranger and more layered than we dare assume. That the great cosmic drama we hope to glimpse might already have played out here more than once and ended in silence. And what if it did? What if we are not the beginning of the story, but the continuation? It changes how we think about progress. We often assume that technology is the apex of intelligence, that the more advanced a species becomes, the more visible its impact must be. But maybe true advancement looks quieter, more adaptive, less destructive. Maybe the highest form of civilization isn't one that covers the planet in concrete, but one that learns how to live within its limits so well that it leaves no geological scar. That idea is humbling, because it suggests that we may still be very young, not just as a species, but as thinkers. It asks us to reconsider the markers of greatness, not just power, but wisdom, not just achievement, but restraint. The Silurian hypothesis doesn't need to be proven to be valuable. Its worth lies in what it reveals about our assumptions, about our place in time, about how little we truly know, even on our own planet. It is a reminder that science isn't just about finding answers, but about asking better questions, ones that challenge us, ones that don't yield easy proofs, ones that make us sit in the discomfort of uncertainty and think, it is tempting to believe we are the first, the chosen, the only ones. But belief is not evidence, and in the vastness of geologic time, where epochs are measured in millions of years and continents, drift like clouds, humility is the more reasonable posture. We may be alone, or we may not. But either way, the Earth has endured much before us, and it will endure much after. The layers beneath our feet are not just rock. They are pages in a book we can barely read, and every now and then, a line shines through, a mystery, an anomaly, a question that resists explanation. We call them curiosities, but they might be clues, not to ancient cities or lost machines, but to the truth that the universe is older, wilder, and more patient than we are. And in that patience, there is wisdom. We don't need to solve the Silurian hypothesis to be changed by it. We only need to let it change how we see the present, to understand that we are not standing on top of history, we are woven into it, that our age, remarkable as it is, may still be part of a pattern older than memory, a verse in a song we didn't start, and maybe, if we listen carefully, we'll learn to sing it better.